Now for this final problem, we're going to have to deal with these log normal problems. And in this case, it's really similar to what we had in the last question, only this time 1 plus it in it. So the last time we let that it be equal to follow a uniform distribution. And now we're going to do a similar thing. We're going to model this as a random variable, but this time this is going to follow the log normal. So log normal distribution, and it has parameters mu with 0.05. So it has parameters mu equal to 0.05, and then sigma squared is equal to 0.0005. And then, as you know from the lecture notes, if this is equal to log normal, if I take the natural log of this, then this is going to be equal to the normal distribution, with a mean of 0.05 and a variance of 0.005. And now we're being asked to find something that pertains to the accumulated value over 5 years. So before I do any calculations, I'm going to consider this term first, S5, and I'm going to define it the same way as I did in the last video. So it's really just the accumulated value from time 0 to time 5. Only all this is all these are random variables. So see that if 1 plus it is a log normal, S5 is also some weird random variable that is the product of 5 log normal distributions. So the distribution of S5 is not very apparent. We're not really sure what exactly it is, but it's easy to find the distribution of S5 if we take the natural log. Because if we take the natural log, this becomes natural log of all these products. And as we know from logarithms, we know that log AB is equal to log A plus log B, right? So we're going to use this directly. So this is just going to be the sum of 5 of these 1 plus I terms, and each one of these, so each individual natural log 1 plus I sub I terms is going to follow the normal distribution, as we've explained here. So each one of these are going to follow the normal distribution. So if you add them up, this is still going to be a normal distribution. If you go back to 2901, I think it'll tell you that the sum of normal distributions is also a normal distribution. And in particular, in our case over here, so we have this sum of 5 identical normal distributions. So this should be an I. So if you sum this up, this will still be normal. And then if you're just adding up 5 normal distributions, that means they just add together. So you take 0.05 and you multiply it by 5. That's 0.25. And the same goes for the variance. So if you're unsure why the variance just adds up, first notice that if all of these are all independent. So if you go back to your 2901, I think they'll teach you this formula. Equals to 2 covariance x1 and x2. And if they're independent, then x1 the covariance is just 0. So it's perfectly valid for us to add up everything, even though it's a variance. So for the variance of the sum of these 5 terms, they're all independent. We just take this and multiply by 5, so we get 0.0025. So this is what we found. We found that the natural log of S5 follows this distribution. So how is this useful? So now let's go back to the original problem. We have $100 at time 0, and then we need to accumulate it for 5 years, and then we want to find the probability that it will be between $115 and $135. So what we're trying to find is that the accumulated value, so we're going to come up with an expression for this, is between these two numbers. So what is an expression for the accumulated value? So S5 is the accumulated value. We're bringing things from time 0 to time 1 to time 2 to time 3, but we're actually just bringing $1 all the way from time 0 to time 5, right? So now we have $100. So the question, we have $100 instead of $1. So the expression for this is just multiplying it by 100. So 100 S5, this is a random variable that tells us the amount that we have at time 5. So dividing 100 to both sides, we get something like this. And then taking the natural log of both sides. So now you see why we found the distribution for natural log of S5. So from the calculations that we did before, we know that this is a normal distribution, and then in order to evaluate the probability of a normal distribution, all we have to do is just to normalize this term, and then we can use our normal tables. So to normalize everything, we just minus both sides by the mean, 0.25, and then divide it by the standard deviation, so square root of 0.0025. So z is the standard normal. Standard normal is where mean is 0, standard variance is equal to 1. So there should be a natural log here. So I left that out. So natural log 1.35 minus 0.25, and then divided by the standard deviation. So this process of minusing the mean and then dividing it by the standard deviation, this is normalization, turns this into the standard normal. And then if you substitute these numbers into your calculator, you'll find that you'll get something like this. So now you can substitute this directly. You can look up your normal tables to calculate this, and then once you do that, you'll find that this is equal to 0.8281. So there's an 82.81% that your accumulated value is going to be between these two numbers.